Ashley's online. Excellent. So that leaves Diana. Yes, and Edlin. First try. And oh, Naomi just joined us. All right, that means we got everybody. Fantastic. You're all here. So, good morning, everyone. Today, we're going to do a couple things. First, we're going to go back to Monday's stuff, and I'm going to show you the answers for that. And then we will do the formal lesson on law of syllogism. We'll see the official notes and then just practice those questions, all right? So please take out your Monday homework if you have it handy. If you don't have it handy, well, you'll have to come back and watch the YouTube video again to check your work later. All right? So the symbols of logic from Monday. There we are. Number 1, if P then not Q looks like this. Number 3, if Q then not R looks like this. And number 5 was the tough one. It is not true that if R then S. So they're setting us up for it is not true that. So you're going to start with a negation, squiggle, around the whole thing. It is not true that all of this happens. All right, and similarly, down here, 7. If the buildup of nuclear weapons continues, then the destruction of civilization could result. We could set that up as just S arrow R. Number 9, it is not true that if the buildup of nuclear weapons does not continue, then international tensions are reduced. Notice that double negation there at the beginning. It is not true that this does not continue. So you get not all of, not S, then Q. All right, and then 11, 13, 15, written here. If the buildup of nuclear weapons continues, then international tensions are not reduced. We're just translating here, right? All of these different things kind of say maybe similar things. Does it say the same thing? That's where that analysis comes in. Some of these might be true, some of them might not. If world peace is not in jeopardy, then the buildup of nuclear weapons does not continue. And 15, it is not true that if the buildup of nuclear weapons does not continue, then the destruction of civilization could not result. Okay, questions so far? All right, then next set. 17 is modus ponens. 19, there is no valid conclusion there. They gave us the wrong one. You can't start with the conclusion here. You got to either negate it or give me the hypothesis. 21 negates the conclusion. That's modus tollens. And 23 is kind of sneaky, actually. You could think of it as modus ponens twice, right? We've got T, then not P. They give us T. So from these two statements, we can conclude not P. And then you use that one with this, not P, leads to not Q. So that's a second set of modus ponens to get to not Q. Or, now that we know a third one, law of syllogism, we can go back to this problem and say, I can reduce these two conditional statements down into just one that goes straight from T to not Q. We give T, we conclude not Q. So it could be modus ponens, or you could do law of syllogism, then the modus ponens. So there's going to be more than one way to deal with these things. Yes, the rules are very strict, but the things they are applying to are complex enough that there's more than one correct answer, more than one right path forward. All right, 25. If the treasure is discovered, then pirate Rufus T. Ruffian will walk his own plank. The treasure is discovered. Therefore, pirate Rufus will walk his own plank. Modus ponens. If you call those statements T and P, then your format will look like this. Okay. Number 17, if Chrissy is an athlete, then she scores high on spatial visualization tests. Chrissy scores high on spatial visualization tests. We have no valid conclusion from that. We don't know anything about her being or not being an athlete just from the high score. Right? Could be some totally different factor that contributes there. Number 29. If angle B is the largest angle in triangle ABC, then the measure of angle B is greater than 60 degrees. Angle B is the largest angle in triangle ABC. Oh, therefore, the measure of angle B, I've cheated and used a bit of shorthand here. We'll cover that shorthand later. But the measure of angle B, however you write it, is greater than 60 degrees. That's just modus ponens. And you could reduce that argument to this guy right here. You don't need to know anything about the actual geometry involved. Just follow the structure. All right, that was it. Any remaining questions from Monday's Symbols of Logic? No? All right, then. Let's move on to logic lesson number 4, the law of syllogism. We saw an excellent example in that Monty Python clip yesterday. Here it is, formal version. Right, go ahead and pull it up on Google Classroom. The law of syllogism, shorthand LS. If you accept if P then Q, and you have if Q then R, if those are both true, well then it also must be true that if P then R. Okay? And that's just writing out what we've already seen symbolically. I would reduce it just to this. Now we have those handy dandy symbols. Make use of them. Law of syllogism is if P then N, if N then S, therefore if P then S. That's all we need. That's the law of syllogism. Turns two conditional statements down into one conditional statement. Very handy for reducing an argument. And if you think back to the Sherlock Holmes stuff we saw at the beginning, that's what he was doing, right? He was saying, okay, If Watson had chalk on his hand, then he was playing billiards. If he was playing billiards, then he was playing with Thurston. If he was talking with Thurston, then he was talking about this investment, right? We had all of those. But the way he first talked to Watson, when he first comes into the room, he says, I see you've got chalk on your hands. I know you're not making the investment. It's like, what? How did you do that? Because really, Sherlock Holmes was combining all these conditional statements in one giant chain of law of syllogism and just presenting the final result, which sounds way more impressive. He left out all of the middle steps. Okay? That's what a lot of impressive, smart people do, right? They just leave out all the middle steps, right? Someone comes up to you with a gigantic, complex algebra problem, and they solve the answer right away. Like, how'd you do that? You just looked at it, no. It's like, no, they worked out all the steps. They just didn't tell you about that. Right? Okay, and we've got a couple samples there, fairly straightforward. Remember, you don't have to go in that order. Whatever order they list them in is okay. I could rearrange this. I could pick up that R then P, and I could put it here, and notice, oh, there we go, the P overlaps, cut out the middleman, go straight to RQ, even if they tell us in a different order. But this is where it gets interesting. Logical arguments, actual logical arguments, most often are going to contain more than one logically valid reasoning pattern. Okay? Just like that, what was it, number 25 from 3, right? That had double modus ponenses. That's what we've got going on here. If I study all night, then I will miss my nighttime soap opera. If Janine comes over to study, then I will study all night. Janine comes over to study. Therefore, put them all together, I'm going to miss my nighttime soap opera. What a shame. I will never find out what happens. Will they get married? Will she reject him? Who knows? Right? If P, then Q. If R, then P. So we can say, like, step 1 would be take these two things and create if R, then Q by law of syllogism, right? Hey, I've got two conditionals. I've got a matching statement on two ends. Let's put those together. And then, now I have R, if R then Q. I can put those two together to conclude, therefore, Q, right? And that process was modus ponens, right? You see the two steps we're doing here. So just like algebra class, you started with x minus 5 equals 10, solve for x, one-step equations. And then you went up to 2x minus 5 equals 12. Now it's a two-step equation, right? That's what we're doing here. We're building it up. Multiple layers. Okay. Oh, and they did it a different way. See, I looked at it as, I like law of syllogism, because to me that makes things simpler first. I like trying for simpler first. But you could also see it as two steps of modus ponens. If R then P, I was given R, so my conclusion is therefore P. And now that's a new statement I can apply and use on the if P then Q. I have the P, therefore Q, also by modus ponens. Okay? Just like that problem from Monday. You can go use either method, you'll get the same way. All right, let's walk through this one more example, and then I'll leave you to it. If the consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. You remember rhombuses from elementary geometry? That's the definition there, right? All the sides are the same size. If the parallelogram is a rhombus, then its diagonals are perpendicular bisectors of each other. Ooh, that's a fancy sounding feature. The diagonals are not perpendicular bisectors of each other. Oh, shoot. It's not the case. Oh, bummer. Therefore, the consecutive sides of the parallelogram are not congruent. Right? So first, let's break it down. We've got if P then Q, consecutive sides leads to rhombus. Right? And then rhombus leads to perpendicular bisectors, if Q then R. But we said not R. That is not true. So again, we could combine these two. Those Q's match up. P then Q, Q then R. We get if P then R by law of syllogism. And we said not R. So when you combine it with that, by modus tollens, it can't be the case that P is true. You could also do this as two sets of modus tollens. We could say not R gives us not Q by modus tollens. The diagonals are not perpendicular, so it can't be a rhombus. And if it's not a rhombus, then the consecutive sides can't be congruent, right? Either way still leads you to the same answer. You can justify it two different ways. Both will work. Or you could look at it this way, right? I like the diagram here. We got all the parallelograms ever. Some parallelograms are rectangles. And then some rectangles are squares. It's a layer inside a layer, right? This isn't any different than the ones we've seen before, except now we've got 3 circles instead of 2. One more step, one more layer, okay? You visual people there. All right, any final questions before I leave you to the exercises? All right, then today you are doing just the odd questions. I'm going to emphasize that. Apparently I forgot to say it last time, and some people did the whole thing. Just the odds. We've got starting off fairly simple with just the symbols. Then we'll go into our written arguments for you to deduce and analyze. And then towards the end, 13 through 17, you're not necessarily using a specific argument style. You're not identifying it. This is a more general problem. So for example, 15, good old tic-tac-toe. Remember when we played ultimate tic-tac-toe? That was great, right? What are the positions O should not play because doing so will allow X to win? Explain. Try to apply these rules of logic to this. If O plays here, then this would happen, then this would happen, X would be able to win. I don't want that to happen, right? If O plays here, then X could play there, and it would, right? So work through that, write out the logic of if, then. We're going to assume X is always playing the best move here, okay? Write it out that way. So it's not necessarily you're going to set up a modus ponens or law of syllogism argument specifically. But now that you have these tools, let's start applying them to some more realistic situations where everything isn't already given to you in that format, right? Especially 17. Right? Can you prove she was speeding sometime during your trip? Right? Pretend you're the lawyer and be like, no, I got you on this, right? You did this, you were here, this happened. Present that argument. We'll see if we can break it down into modus ponens and modus tollens, law of syllogism stuff next week. All right, then with that, I'll leave you to it. 1 through 17 odd, okay? What's it, 25 minutes to work.